During today's class, you created several figures together using the hinged mirror. And you kept these three questions in mind. Is there another way to create the figure? And you actually found at least two ways to create the equilateral triangle. What types of symmetry can I find? You were using reflection symmetry, and in some cases even rotational symmetry. And what does the symmetry tell me about the polygon? And that's an important question. What does the symmetry tell me about the polygon? In Unit 7, you'll be asked to understand certain characteristics that are true for certain quadrilaterals. For example, you created a rhombus today by making a 90-degree angle with your hinged mirror. And by changing the orientation of the two sides of the hinged mirror so that your reflection created a rhombus, something like this. Now, because the hinge angle you created, or the core region angle, or central angle you created was 90 degrees, that had no choice but to create diagonals that are perpendicular. So reflection symmetry of this 90-degree angle, where A exists here and A prime exists here, B exists here and B prime exists here, tells us that the diagonals of a rhombus must be perpendicular. And along those same lines, we're told that by reflecting a right triangle, we can build a rhombus by reflecting that right triangle once, twice, and a third time. So this is an important characteristic of rhombi. The diagonals will always be perpendicular, and that's true even when the rhombus is a square. Sometimes you're asked to prove that by finding the slopes of diagonals and showing that those slopes must be perpendicular because they're opposite reciprocals. Sometimes you're asked to show that by reflection. When you made the regular hexagon, you did so by repeating a core area that was isosceles, and in this case also equilateral. So equilateral and triangular, this was reflected 5 times. To create the regular hexagon. Regular meaning all sides have the same length. Again, reflection symmetry assured that this figure would be regular. And you should be reminded that 360 divided by n equals the central angle, where n is the number of sides in the figure. And in that same way, you created an equilateral triangle by opening your hinged mirror up to the 120-degree angle and reflecting the core region once and twice. 360 divided by the 3 sides of the triangle equals 120 degrees. You also used reflection symmetry to create the equilateral triangle by reflecting the 30, 60, 90 triangle. So you used reflection symmetry in several ways today, and you discovered rotational symmetry as well. Question 7-42 asks you to examine the regular octagon and find theta. The central angle in this case equals 45 degrees. You were also asked to consider quadrilateral ABCD, which is a rhombus. The diagonals were drawn in. We're told that BD is equal to 10 units. The easiest way to indicate that is to put two 5s in. BE is 5 and ED is 5. And we're told that AC is 18 units, so I'll make AE 9 and EC 9. And we're asked what the perimeter is. Well, if these are right triangles with equivalent sides, I need to find any one of the side segments, which is the hypotenuse of any triangle. I'll use ECB. 5 squared plus 9 squared equals the length of BC squared. 25 plus 81 equals the length of BC squared. Square root of 106 equals square root of BC squared, which is BC. BC then is approximately 10.3. Therefore, the perimeter 4 times the square root of 106, which is approximately 41.18 units. The regular polygons math notes, methods and meanings box that follows this unit is an important box to get to know. You'll need to be able to describe the central angle for each of these 5 figures as well as others. So pay attention to that box and review the concepts I've just covered.